Okay, we're ready for the second video. And the second video on this topic, we're going to be looking at direct variation. The idea behind direct variation is that when one item changes, another item changes. So you change an independent item, that causes a change to a dependent item, and you can predict how the dependent will change when you change the independent because there's a consistent pattern. In fact, we call it the constant of variation. The way we find the constant of variation is first we identify the dependent and the independent items. And remember what we said, the independent is the thing you control, and the dependent is the thing that the independent controls. So in this case, what you control is the weight, and that makes the weight the independent variable. Independent. Right there, the weight. The weight controls how far the spring stretches. So that makes the spring stretching the dependent amount. You control how much weight you put on the spring. When the weight goes on the spring, it causes the spring to stretch. Here's the pattern that we know. When you put 2 pounds of weight, it stretches the spring 7 pounds. When you put 4 pounds of weight, it stretches the spring 14 inches, and so on. To get the actual constant of variation, we always use this formula. We always take the dependent amount and we divide it by the independent amount. That's always the idea, the dependent amount divided by the independent amount. And remember, by the time you're watching this video, we've already started Week 14's concept. And what we know from the Week 14 concept is that this dependent amount is always shown as y on our graph, and the independent is always shown as x. So I'm going to remind you of that now. You'll need that when you take the Week 14 test. So let's take a couple of these amounts and try them out. 7 divided by 2. 7 divided by 2. Well, 2 goes into 7 3 times. That's 6 with 1/2 left over. 6.5, or 3.5, excuse me. Let's take 14 and divide it by 4. And let's use long division this time. 4 goes into 14 3 times. That's 12. 2 left over. Bring down a 0, bring up a decimal. 4 goes into 20 5 times, which again is 3.5. So for this relationship, the constant of variation is 3.5. And if you showed it as 3.5, that's just another way of saying 3.5. So that takes care of the first part of our question. The second part is write an equation you could use. You have to be really careful with this. You could use to find the distance the spring stretches when given a weight. So you put a certain weight on, how far will the spring stretch? You have to be sure you read these carefully because you have to do them in the right order. And the formula would be this. Whatever weight you put on times 3.5 will give you the distance. I'm going to change this to the x style so we don't get mixed up with that decimal. So 3.5 times the weight. Written out as a sentence, it would be weight times 3.5 equals distance. And you could check that against any one of these. 35 equals 10 times 3.5. 28 equals 8 times 3.5. Okay, remember this is an A problem. You're going to see this 2 more times. So if you have questions still, be sure you ask in class.